video of the chapter, we're going to do the last lesson about modulus functions and how they look visually. Okay, so here we're given some function. We can be told the function, but this isn't necessary. We can just be shown f of x, and we have to sketch the modulus of the whole function, and then we also have to sketch the modulus of x, then put into the function. So what's this going to look like and why? Well, first of all, a shouldn't be too bad, because we know if you take modulus, it takes all your negative values and it makes them positive. 0 will stay as 0, positives will stay as positives, and we're expecting these negatives to be reflected in the x-axis. So something like this. And that's what we have. Okay. Also, with any points, if possible, we should try and mark them as well. So it was -3 was the y-intercept from before, so that's going to be 3 now. Okay. How about the next part? Because the next part is a little bit more difficult. So we're going to take any values of x that we've got, make sure that they are positive, and then put them into our function. So let's pick some points to understand what's going on. So if I pick the point 3 and I take the modulus, I'll still have 3. And when 3 goes into the function, you get 0. So that's not going to change. What about if I have a point over here? So imagine this is 1. 1, you make sure that 1 is positive, and then you put it into the function. So that's going to stay the same as well. The change is going to be on the left-hand side here with the negative x values. So if I have -1, what's going to happen? I'm going to make it positive. So remember, this is all starting with -1. I'm finding out where to plot the y part for -1. So I make -1 positive, I make it 1, and then I put 1 into the function. What's the answer going to be? Well, it's going to be whatever the answer was when you had +1 going in here. So in other words, this -1 is going to steal the same y coordinate as its positive version. Okay, so it looks something like this. -1 is going to have the same y value as 1 had. We also know about -3 now, don't we? Because -3 will give you the same y value as 3 gave you. Let's have a look at another example. So here I've got x squared minus 6x plus 4, modulus of the whole thing. Again, the same as before. Notice this sharp shape here. And again, you don't need to worry about how I've made this, but I'm taking the modulus of x here, and then I'm putting it inside the function. So what does it do? Well, it does something like this, like a butterfly shape. Okay, the left-hand side mirrors what the right-hand side is doing. It's a perfect reflection down the line x equals 0, the y-axis. So if you're -1, you steal the y value from the 1. So they're both the same. And the same for -2 and -3 and so on. It's a really quick question that you can get quite good at and get quite a few marks. Another variation, so after we do these, is we perhaps sometimes have to think about some coordinates. Some of them will stay the same, some of them will change. Okay, but the idea for the first one is just make it all above the y-axis, and for the second one, the left-hand side is going to get whatever the right-hand side already has. Okay, we can also do this for sine functions, cos functions, things like that as well.